these two problems are also similar. Well, I guess before we get into it, I'll specify this is Stewart Calculus 8th edition, section 1.1. We've got problems 20 and 21. They're similar to that previous video with 16 through 19, where it just says to describe a scenario and sketch a graph for it. So problem 20, it says you place a frozen pie in an oven and bake it for an hour. Then you take it out and let it cool before eating it. So describe how the temperature of the pie changes as time passes. Then sketch a rough graph of the temperature of the pie as a function of time. Okay? So, okay. Well, let's just talk about it first. So you've got the pie, it's frozen, so that means it's cold, right? I know that might be really obvious, but it's definitely good to really get these obvious things understood, especially for future problems. It can make your life a lot easier. So, okay, so the pie is frozen, so it's cold, right? Then we bake it for an hour, so it heats up, it gets unfrozen and bakes, right? Then you let it out, you take the pie out and it cools off. Okay, so it's hot and it gets colder. Okay, so let's go ahead and describe that with a graph. So what happens is we have temperature. Let me rewrite that a little bit further to the left. We'll say degrees Fahrenheit. And the pie is frozen, so maybe 20 degrees. We'll do 60-degree intervals, so 80, 140, and maybe 200. Then on the bottom of the graph, we'll have how long? An hour? So we'll do 30-minute intervals. 30, 60, 90. And this is time in minutes. Good. Okay. So we take the pie out of the freezer. We bake it for an hour. So we bake the pie, it gets really hot, and actually that curve is going to look a little bit different. It's going to heat up the fastest first, and then it's going to slow down. We'll get more to why that's the case. I think it's around chapter 4 or so, maybe 3. And so with Newton's heating and cooling. But anyways, so it heats up, and it does continue to heat, but the rate of heating slows down. Then we take it out of the oven, and it cools off a little bit. And yeah, it'll look something like that. Yeah, that's it for that problem. So 2021. Okay, so 21, we have to be a little bit more careful. A homeowner mows the lawn every Wednesday afternoon, so it's very exact when they mow the lawn. Sketch a rough graph of the height of the grass as a function of time over a 4-week period. Okay, 4 weeks, they're very particular with what they want. Every Wednesday, we have week 1, 2, 3, and 4. And let's say the height in inches is 1, 2, 3. So right here it's at 1. And here's the trick with this. It's going to grow, and then right at, well, let's just take a minute and actually label the graph first. So we have height in inches. And then down here we have weeks. But anyways, at week 0, that's where the grass was just cut, so it's starting out. And then right as he cuts the grass, we're going to have an open circle. then a closed circle. And the reason for that is because the grass does not just rapidly shrink. It doesn't do that, right? What happens is it gets to a certain height like this, and then the lawnmower blade cuts off this top part here. So there's no shrinking. It's just an instant jump from tall to short. And that's the only slightly tricky part with this problem. And so he does this every week, and it's going to be exactly the same because this person seems to be very particular with what they want. And there we have it. That's a function of what happens to the grass height. It grows about 1.5 inches every week, and then it gets cut down back to 1 inch. And that's it for problems 20 and 21. Thank you.